Hello everyone, welcome back to Think Lab by Saurabh. So in today's video, we are going to learn one of the most important topics in Retrieval-Augmented Generation, right? The topic is embedding. So many people think choosing the latest LLM is enough to build a great RAG system, but that is not true. So without good embedding, even the best LLM cannot retrieve the right information. So today we will understand the 7 embedding strategy used in the modern AI, right? So let's get started. So what is the embedding, right? So first let's understand what is the embedding is. So an embedding is a numerical representation of data. It converts text into the list of number that is called the vector. So this vector captures the meaning of the text. So instead of matching the exact words, AI compare this vector. So if two vectors are close to each other and their meaning are similar, so this how the semantic search works. For example, the word car and the automobile are different, but their embedding are very close because they have a very similar meaning. So this allow RAG system to find the relevant information even when the exact word are the not used, right? So now let's explore the 7 embedding strategy, right? So the number one strategy is dense embedding. So the first strategy is dense embedding. So this is the most commonly used embedding type. So each document is converted into the dense vector and every value in the vector contains the semantic information. So dense embedding understand the meaning of the sentence and they work very well for natural language. So they can find the similar idea even if the different word are used. So this why most modern RAG system use dense embedding. So they are ideal for the chatbot question answering and the semantic search. Now we are moving to the strategy 2. We call the sparse embedding. The second strategy is a sparse embedding. So like dense embedding, sparse embedding focus on keywords. So they remember which important words appear in the document. So this makes keywords matching very accurate. If a user search using the exact technical terms, so sparse embedding perform very well. So traditional search engines often use this idea. So sparse embedding are useful when the exact matching is more important than the semantic similarities, right? So they are commonly used together with the BM25 retrieval, right? So now we are moving to the strategy 3, hybrid embedding. So the third strategy is hybrid embedding. So this combine the dense and sparse embedding together. So dense embedding understand the meaning, sparse embedding understand the keyword, right? This is the hybrid embedding. So we are using the dense and sparse together. So dense embedding is best for the understanding the meaning and the sparse embedding is understand the keywords. So together they provide the best of the both worlds, right? So if the semantic search missing something, so keyword search can the find the still the find it. So this improve the recall and ranking. So many enterprise search system now we use this hybrid retrieval because it's deliver the better search quality. The strategy 4 is multi-vector embedding. So the fourth strategy is the multi-vector embedding. Normally one document has one embedding vector, but the long document often discuss many different topics. So one vector cannot represent everything accurately. So multi-vector embedding solve this problem. So instead of one vector, multiple vector are created. So each vector represented a different section or concept. So this allow more precise retrieval. So it works especially for books, research paper and technical documentations. The strategy 5 is the instruction tune embedding. So the fifth strategy is the we call the instruction tune embedding. So this embedding are trained for the specific task. For example, one model may be optimized for search, another may be optimized for the question answering, another may be optimized for coding. So because they understand the task, retrieval becomes more accurate. So instruction tune embedding improve the query understanding and they widely used in the AI assistant and production RAG system, right? So now we are moving to the strategy 6, multimodal embedding. So let's discuss the multimodal embedding. So this embedding work with the multiple types of data, not only the text, they understand the image, audio, video and sometimes the document. So everything is converted into the shear vector space. So this means you can search using the text and the retrieval of an image or upload an image and retrieve the related document. So this technology power many modern visions AI applications. So it's belonging the increase the important in the enterprise AI. So seventh one is the strategy 7 is the domain specific embedding. So finally we have domain specific embedding. So general embedding model are trained on a wide variety of internet data, but specialized industry required the specialized knowledge. So medical document use the medical terminology, legal document use the legal language, and financial report use the financial concept. So scientific research contain the technical vocabulary. So domain specific embedding are trained on this specialized data. So as the result, retrieval accuracy becomes much higher. They are widely used in healthcare, law, finance, and the scientific research. So which strategy should you choose, right? So now the question is, which embedding strategy should you choose, right? So if you need general semantic search, use the dense embedding. If you exact word matching is important, so use the sparse embedding. If you want to best overall performance, choose hybrid embedding. For the long document, you can choose the multi-vector embedding for the great options. For AI assistant production system, so you can choose the instruction tune embedding, perform very well. So if your application use text, image, audio together, so choose multimodal embedding. And if you work in the healthcare, finance, legal or research domain, specific embedding, so will give you the highest accuracy. So at the end of this video, the final summary is, so let quickly summarize today's lessons. So dense embedding capture the semantic meaning. Sparse embedding focus on keywords. Hybrid embedding combine the semantic search and the keyword search. Multi-vector embedding represent the multiple concept in one document. Instruction tune embedding are optimized for a specific task. Multimodal embedding work across the text, image, audio, and video. Domain specific embedding are trained for the specialized industries. Remember this simple formula: better embedding leads to better search leads to the better context lead to the better AI answer. So if you are building an AI agent or production rack system, so choose the right embedding strategy is just as important as choosing the right LLM. So I hope this video help you to understand the embedding in a simple and practical way. If you learned something new today, so please like this video and share with your friend and colleagues, and don't forget to subscribe the Think Lab by Saurabh for more AI, machine learning, data science and GenAI tutorials. So thank you for watching. See you in the next video. Happy learning.